Good evening, everyone. Today, let me discuss about the sedimentation aided with the coagulation. Good evening, students. Today, we'll discuss the problem of sedimentation aided with the coagulation. So, let me solve this problem. It's a very simple problem. Okay, let me discuss. Okay, let me solve. It's a very simple. By knowing the reaction of alum along with the calcium bicarbonate, so we have to solve the what is the amount of carbon dioxide released from the some quantity of the alum. Okay, let me discuss. So let I start the problem. Okay, determine the quantity of alum which is required to treat what 13 mld of water at a treatment plant. So here the problem which was given is to treat 13 mld of water at a treatment plant where the 12 ppm of alum dose is required. 12 ppm of alum dose. ppm is nothing but the parts per million, or we can also say that milligrams per liter. Okay, same, both are nothing but same. Parts per million are mg per liter, that is a milligrams per liter. So where 12 ppm of alum dose is required, also determine the amount of carbon dioxide gas which will be released per liter of water treated. So we have to determine what is the alum, that is what is the alum which is released from the carbon dioxide, which will be released per liter of water treated. How much carbon dioxide will release, we have to find out. So for that, what is the alum formula? The alum formula is a good coagulant to treat the water. So we know the process. What is the sedimentation aided with the coagulation means the process of adding the coagulants, that means the chemicals, to the water. So the suspended and the fine suspended particles will coagulate with that coagulants and form a flock to make into a heavier substance that will settle at the bottom of the tank. That is the process of sedimentation aided with the coagulation. Okay. So here what is the alum formula? The alum formula is Al2SO4 thrice 18H2O. That is whole. That is the whole formula. That is Al2SO4 thrice 18H2O is the alum formula. The chemical reaction involved in treating the water with the alum. So I will show you. I will write it and show you. So the alum formula. What is the alum formula? Say once again. That is Al2. That is Al2SO4 thrice 18H2O. So this is the alum formula. The chemical reaction which is involved in the water is Al2SO4 thrice 18H2O is the alum which we are added into the water. That means the waste water to remove the suspended particles. When it is combined with the calcium bicarbonate, CaOH, what is the, that is a CaOH, CaHCO3, sorry, calcium bicarbonate, it is CaHCO3 twice. So this is what the calcium bicarbonate is, the salt which is present in the water, and this is a coagulant which we are added, that is Al2SO4 thrice 18H2O is the alum, that means the chemical which we are used. And in water there is a presence of calcium bicarbonate, that is the CaHCO3, that means HCO3 is the bicarbonate, calcium bicarbonate, and it gives rise to the reaction. So what is the reaction? That is a 2Al, that is a aluminium sulfate, that is a Al2SO4 18H2O. It is whole, we call it as a alum. 2Al, and the reaction is, that is 2Al OH twice, OH thrice, plus 3 CaSO4 calcium sulfate, plus 18H2O, plus 6 carbon dioxide. The carbon dioxide gas which is evolved when the alum is added to the water. So 6 CO2, we have to find out what is the amount of carbon dioxide gas which will be released per liter of water treated. So we have to find out what is the carbon dioxide gas which is released per liter of water. We have to find out. I think now you understood what is the concept. This is the formula. This is the basic. When we used to solve the problem, this type of the problem, we have to know at least, we have to buy it, the alum reaction, that means the alum formula, that is Al2SO4 aluminium sulfate into 18 times of H2O, that forms the alum, that is Al2, that is Al2SO4. Say once again the formula. Alum formula is Al2SO4 thrice 18H2O is the alum. When it reacts with calcium bicarbonate which is present in a water, CaHCO3 twice, the reaction gives rise to the, that is 2Al OH thrice plus 3 CaSO4 calcium sulfate aluminium hydroxide plus calcium sulfate plus water plus carbon dioxide. When the alum, when it is reacts with the calcium bicarbonate, it gives rise to water, carbon dioxide. So in this particular problem, they asked to calculate how much carbon dioxide will released per liter of water. Okay, so first we have to determine the quantity of alum required in order to treat the 13 mld of the water. Okay, so to treat 13 million liters of water, how much quantity of the alum is required? First we have to determine. Okay, so first we have to determine, to treat 13 mld of water, that means the water to be treated, is equal to, that is 3 into 10 raised to 6, that means 13 into 10 raised to 6, that is 13 million liters. So how much quantity of the alum is required? Alum dose is required. So 12 milligrams per liter. So per liter it is required 12, but it is in terms of milligrams per liter, mg per liter. That mg should be converted into terms of kg. Milligrams should be converted into kg. That means 1000 into 1000. Then this will become 13 into 10 raised to 6 multiplied by 12 into 10 raised to minus 6. 1000 into 1000, when it is goes up, it is 10 raised to minus 6. What happens? Then it will give the value of 156 kg. So per day, so now per day 156 kg of alum is required to treat 13 million liters of water per day. So for first question, determine the amount of alum required in order to treat the 13 million liters of water is 150 kg. In terms of kg, we are talking about, that means 156 kg of the alum is required per day to treat the 13 million liters of water. Okay, the first we have find out the how much quantity of the alum is required to treat the 13 million liters of water. So that is 156 kg of alum is required to treat the 13 million liters of water. Okay, the first one is clear. That is the in solution quantity of water to be treated is 13 million liters per day. Alum dose required in the problem itself, it is given, it is 12 ppm or 12 mg per liter, and the amount of alum required per day is, we have to find out, that is 13 into 10 raised to 6 into 12 into 10 raised to minus 6. How come the 10 raised to minus 6? Because it is milligrams, that should be converted into kg, that means divided by 1000 into 1000, that means 10 raised to minus 6, that is 150 kgs of the alum is required to treat the 13 million liters of the water. Okay, so now we have to use the what is the chemical reaction involved in treating with the alum. So we have to write that chemical reaction, because we have to find out, and the second case we have to find out the what is the amount of carbon dioxide gas will release per liter of water per liter to treat. So here in the problem here is given as 13 million liters of water is to be treated. So in this to treat 1 liter of the water, so how much carbon dioxide is released, we have to find out. Okay, then the chemical reaction is Al2SO4 thrice 18H2O plus CaHCO3, it gives rise to 2AlOH thrice plus 3CaSO4 plus 18H2O plus 6CO2. And for alum formula, that means Al2SO4 thrice into 18H2O. For that we have to write what is the molecular mass of alum. So how to calculate the molecular mass of the alum? So here we have Al2SO4 thrice 18H2O is the chemical formula. Okay, to find out what is the molecular mass, we can easily remember what is the alum molecular mass. Okay, so alum molecular mass, but you have to substitute and you have to show it's a 666. The molecular mass of the alum is 666. Then how to calculate this, the molecular mass of the alum? So first we have to know the molecular weight. First we have to know the molecular weight of the each component. For aluminium, for aluminium so what is the aluminium molecular weight? The aluminium molecular weight is 27, or it is 26.97. 27 or 26.97. And the oxygen molecular weight is 16, and the oxygen molecular weight is 16. So let us show. So here the molecular weight of the aluminium is 27 or 26.97, and the oxygen is 16, and the hydrogen is 1, and calcium is 40, then carbon is 12. These are the molecular weights of the each component. So now look at here. The molecular mass of the alum is 666, that is a 666 we have find out. How means, so Al2 means the 2, Al2 means that is the 2, Al2. What is the aluminium molecular weight? So it is 26.97. Al2, that is Al2, aluminum molecular weight is 26.97 and multiplied with 2 plus Al2 SO4 thrice. So thrice it should be multiplied with the ol and the sulfate, that is the SO4, and the sulfur, that means SO. So the S is different and the oxygen is different. So for S, sulfur, what is the molecular weight? It is 32. Look at here. Molecular weight of the each component is given. For aluminium it is 27. For sulfur it is 32. For oxygen it is 16. For hydrogen it is 1. For calcium it is 40. And for carbon it is 12. So now we are using that molecular weight. So now 32 is the sulfur, that is the S. Then O, that is the oxygen. So O is that is oxygen. Then O which is multiplied with 4. That means 32 plus 16 is the molecular weight of the oxygen multiplied with the 4. 32 is the S molecular weight. 16 into 4 is the O4 and that should be multiplied with 3 plus again 18H2O is there. So the what is the molecular formula? Al2SO4 thrice 18H2O. For 18H2O, so we have to 18. So H2O, H is hydrogen, it is 1. So here the 18H2O, that is 18 into, it is 2 into 1. So in this sheet it is changed into 12. So sorry for that, that is 2. Make it to 2 multiplied with 1 plus 16. So 2 multiplied with 1 is nothing but that is H2O. 18 H2 is the 2 into 1 and O for oxygen molecular weight is 16. So this will gives the value. So what is 666? This will gives the molecular mass is, that is 666. In this sheet I think it is seen, that is 2 into 27 plus 3 into 32 plus 16 into 4 plus 18 into 12. 2 into 1, instead of 12 you have to take 2 into 1 plus 16. So here and the value it becomes 666. Okay, the molecular mass of the alum is, that is 666. And the molecular mass of carbon dioxide, that is CO2, the molecular mass of the carbon dioxide, that is CO2. So here the CO2 carbon is 60. What is the carbon value? It is 12 plus what is the oxygen? 16 into 2. So this will gives the value, that is 44. 44 carbon dioxide. So look at here. Molecular mass of carbon dioxide is equal to 12 plus 2 into 16, that will becomes 44. Now it means that 666 milligrams of alum will release. So carbon dioxide, how much carbon dioxide is released in the formula in the chemical reaction? That is 6 CO2. That means 6 into 44. That is 6 into 44. So now we have to calculate. The 12 ppm of alum. So how much carbon dioxide which is released from the 12 ppm of the alum? That means a 12 milligram per liter of the alum will release how much quantity of the carbon dioxide we have to find out. Therefore, the 12 ppm of alum will release 6 into 44 is the carbon dioxide, that is a 6 CO2. 6 into 44 is the molecular mass of the carbon dioxide, divided by 666, it is the molecular mass of the alum, multiplied with 12 mg per liter, it is the alum dosage. So that gives 4.76 milligrams of 4.76 carbon dioxide will be released from 12 ppm of the alum. So how much carbon dioxide will release? 4.76. 4.76 carbon dioxide will released from the 12 ppm of the alum. I think it's clear for you. So once again let me discuss. Before to solve this problem, first of all we should know what is the chemical formula for the alum. What is the chemical formula? The chemical formula is Al2SO4 thrice 18H2O plus 18H2O, that is the chemical reaction. Al2SO4 thrice 18H2O is the alum chemical formula. When the alum is added to the water, in that water there is a presence of calcium bicarbonate, that is a Ca, calcium bicarbonate, HCO3 twice. Calcium bicarbonate is present in a water, then the reaction becomes the reaction which gives rise to aluminium hydroxide plus calcium sulfate plus water plus carbon dioxide. It will releases. The alum, when it is in combination with the calcium bicarbonate, it gives rise to a carbon dioxide. So in this particular problem, they are asked how much quantity of the carbon dioxide will release. In the first condition, to determine what is the amount of alum which is used to treat a particular quantity of the water, that means a 13 mld of the water which we are going to treat, for that how much quantity of the alum is required, that is 150 kg. 156 kg of the alum which is required to treat the 30 million liters of the water. And next thing, to determine the amount of carbon dioxide which will be released per liter of water. So that should be calculated with this formula. That means now the carbon dioxide molecular before that we should remember the chemical reaction as well as the molecular weight also we should remember. Aluminium molecular weight is 27, for sulfur it is 32, for oxygen it is 16, for hydrogen it is 1, for calcium is 40, for carbon is 12. So here these are the molecular weight of the alum. Sorry, these are the molecular weight of these components. These are the molecular weights of these components. So here, so we have calculated both, that is what is the quantity of the alum required to treat the 13 million liters, as well as how much carbon dioxide which is released from the 12 ppm of the alum, that is the 12 milligrams per liter of the alum. So this is the solution for the particular problem. I think you have understood better or clear, I think so. So okay, thank you.